Okay, everybody. Good morning to you guys. I hope you guys are doing well. Let's see. Is it hot in here or is it just me? It's a little warm still. Yeah, I don't know. I don't know how you guys survived the weekend, but was it brutal? It was brutal. It was brutal for me. I was like, wow, horrible. Yeah, sleeping was a nightmare. Oh, it put you to sleep. Wow. Yeah, it doesn't put me. It keeps me awake actually. I guess I just don't like sweating in my sleep. Ugh. Anyway, yeah. Unfortunately, so when is it going to end? Does anybody know? A couple more days of this? Well, like I said, just hang out in the AC at the library. Don't even go home as much as possible, and that's kind of what you want to do. All right, ladies and gentlemen, I'm going to warm up this morning here. I'm going to see what you guys know based on what we did last time. Okay. And here's question number one. We're going to do a few of these here, and we're going to try to see what you guys can do here with it. But anyway, give you guys some time here with this to do a nice warm up. This is question number one, and I'll make it bigger for you guys. All right, ladies and gentlemen. Okay, so hopefully we're nice and awake, and we're going to apply everything we talked about last time. And notice a couple of things here, ladies and gentlemen. What do they want us to do? Right? It says determine the missing side, right? So what do we call the side that's missing here? What's that name? It is C, but what's the name of that? Because you remember, you have a right triangle, and that's the hypotenuse. Is that right? So, ladies and gentlemen, this is the hypotenuse. So, in other words, it's almost like just saying to people, can you please determine the hypotenuse? Now, because it's a right triangle, notice a few other things, right? You have the legs, don't you? So the legs are given, but the hypotenuse is not. So what do you guys use? Do you guys remember? Pythagorean theorem. Okay, so that is c squared is 4 squared plus 3 squared. Or we say c squared is 16 plus 9. C squared is 25. Now what does that mean about c? Plus or minus the square root of what? 25. Now remember, that means two things. That's plus or minus what? 5. Now, since distance is always positive, the hypotenuse measures 5 what? Units. So the hypotenuse measures about 5 units. Okay, you guys okay with that? Anybody have any questions on that part? Right, okay, this is still review, so we can say, the hypotenuse is 5. Good. Now, they also want us to know a few things as well, right? You say, what do you mean they want us to know? They want us to determine some ratios. And you got alpha here. These are the first 3 ratios, right? This is for alpha. And then you have another angle over here called what? Beta. So this is kind of where we left off, in all honesty. Okay, so you have a couple of different angles they're going to ask you ratios for. And then you say, well, what about these others? Well, yeah, they're in reference to the angle alpha, but they're the reciprocal identities, or the reciprocal ratios. And those are in reference to beta, so those are reciprocal. So really you want to do the first 3, and after you get the first 3, you get the next 3. Is that true? Right, you get them free of charge. Why? Right? Why is it easier if you said to you, hey, get always the first what? 3. Sine, cosine, and tangent. And after you get those first 3, why is it easier to get the last 3? They just flip them over. They're reciprocals. Okay? Pretty simple. So really, this is an exercise, in all honesty, in whether you know the definition of sine, cosine, tangent of an angle. Right? Those definitions, and you want to know those definitions. Okay? Those definitions are not going to go away, right? You'll go away before those definitions go away. So what you want to do is remember that, I got to know those ratios. So if they say, for example, sine of alpha, okay? Do you remember what that definition is? Opposite over hypotenuse. Now, opposite what angle? Opposite the what? Alpha. And the opposite side is always the side it opens to. So you say, does that mean it's 4 over 5, the hypotenuse? And the answer is what? Yes. Yeah. Wrong button. The answer is yes. Okay, you guys okay with that? Now, compare and contrast, because this is what's going to happen. Some people are going to go, okay, Mr. Judge, what about that beta, though? If you put sine beta over here, the side opposite beta is not 4. What's the side that beta angle opens to? Is that 3? Right? Over here, this is opposite. And then the hypotenuse still is 5, so it's 3/5. All right, you guys okay with that? So compare and contrast, because it depends on the angle you are referring here, ladies and gentlemen. All right, it depends on the angle you're referring. All right, now let's do cosine. Cosine alpha, what's that definition? Right? If alpha's right here in orange, what's the definition of cosine again? Anybody remember the definition of cosine? It's adjacent over what? Hypotenuse, is that right? So it's the adjacent side now. You go, okay, what does adjacent mean? Next to. I mean, it literally means right next to. So if alpha's here, I got this side and this side that are right next to alpha. But one of them is called a hypotenuse. The hypotenuse never changes. So the adjacent side is 3, hypotenuse is 5, and ladies and gentlemen, you've answered the question here. There's the ratio using the definition. Okay, and now you might say, well, what about cosine of beta then? Well, same definition, but it's a different angle. So you go, okay, well, where's the beta angle? Beta's right here. The adjacent side, you got 2. It's 4 and it's 5, but we said the hypotenuse never changes. So the adjacent side to beta is 4 and the hypotenuse is 5. And ladies and gentlemen, there you go. Okay. So you got different ratios. And the last ratio, tangent. So I want to compare and contrast these here. Tangent is really what? Is it opposite over adjacent for tangent? So tangent of alpha is here, or alpha's there. The opposite side is 4. The adjacent side is 3, so this is 4/3. Okay, and now for tangent of now the other angle, beta. So I could get rid of, this in some ways. You say, okay, beta, opposite beta is 3. Adjacent is what? 4. So this ratio will be 3 over 4. Now, you always want to remember those words, right? For sine, cosine, and tangent. These 3. And like I said, once you get these 3, you get the what? The reciprocal. What's the reciprocal again of any fraction? Is this you flip it over. That's called a reciprocal. To reciprocate. So, there's kind of an interesting device that I use. Like you say, what's the reciprocal of sine? I remember, what did I press? I remember as a student myself going, man, how do I remember? Let me get the eraser here. I remember thinking to myself, how do I remember the reciprocal of sine? Right? Do you guys know what I'm talking about? I mean, I know I could flip over a fraction. I said I could remember that. But what's the word that I use? You guys know what I used to do? This is how I memorized it. If this is sine, the reciprocal is going to be cosecant. Almost like saying the opposite letter of S is C. Similarly, cosine would be what? Secant. You see the C and the S? So I always just remembered opposite letters, even to this day. So if I say, okay, I need the reciprocal of sine, I go, oh, I know what it is. It's what? Cosecant. It's the opposite letter. And then that ratio I can flip over. It will be 5 over 4. There you go. And again, what's the reciprocal of cosine? Well, it's the opposite letter, secant. Just flip that fraction over. Tangent was easy. Why is tangent easy? It's cotangent. It's related to the word cotangent. So that one was easy to memorize. But the reciprocal for sine, I just thought, okay, it's the other letter C. And if they ask me for the reciprocal of cosine, it's that other letter S. Just kind of a memory device for all of this. Kind of easy to remember. So what do you guys think? Is that pretty simple? All of this physical information about a right triangle. And so similarly, opposite of sine, cosecant, beta. Oh, just flip the fraction over. Opposite of cosine would be secant. Flip the fraction over. And opposite of tangent is cotangent. Flip the fraction over. And now, ladies and gentlemen, we've done what they wanted us to do. We found all 6 trig ratios for every interior angle of that triangle. So we're really doing what's known as solving a triangle. You know, we're looking at every bit of information about that triangle. And that's what they want you to do. And then I'm going to ask you guys this important question here, right? There is always a relationship between alpha and beta for any right triangle. Let's see if you guys remember this relationship. What am I talking about? Does anybody know? Yes. They are complementary. That's good. But what does that mean? You're absolutely right. What a complementary angle. What does that imply? That the sum is what? 90 degrees. Okay? Now, this is going to be a very, very, very big deal. Okay? And we actually seen a little bit of it last time, right? So if I go back to my scratch somewhere, is it Geometry Review 1? Algebra Review? No, that's not you guys. Geometry Review 1? No. I did have a sheet. Oh, I called it 241S maybe. Let's see if it's here. Right? This is how we actually used it last time. So what you guys want to do is always remember this is a 45-45 90-degree special triangle. Okay? And your sides will be 1. The legs are 1, and the hypotenuse is the square root of 2. Okay? And then you have another special triangle. Here we go. And we used that idea last time. The 30, 60, 90-degree special triangle. Okay? You guys okay with this? And now, I mean, I'm going to say this is so important here. Yeah, what are we going to do? I'm going to copy this down here. I'm going to copy this. And what we're going to try to take a look at here, again, as review. Is this still review? You guys okay with that? Here's the question. What are the 6 trig ratios for the 45 degree, 90 degree triangle? Right, what are the trig ratios for these triangles? Now you might say, what are you talking about? Well, there's only one angle, 45. What's the other angle? 45. You guys, like if I color coordinate this 45 and 45, right? So you go, oh my God, I don't have to find 12, only 6 because it's the same angle, 45 and 45. So, for example, you'd say, does that mean sine of 45 degrees is going to be what? Use this 45. What's the definition again? Opposite over hypotenuse. All right, you guys okay with that? Sine of 45 is 1 over the square root of 2. It's a numerical answer. Is that true? Do you guys agree with that? Now, but what's the issue? We always have to do what? Rationalize the what? Denominator. How do you do that? Square root of 2 over the square root of 2. What does that equal? Square root of 2 over 2. So the denominator is rational. Is that true? You say, what do you mean rationalize? You see this square root of 2? That's irrational. You see this 2? That's rational. So this is the rationalize the denominator process. We worked with this actually last week as well. You guys remember? We went over these kind of things. So ladies and gentlemen, there you go. Sine of 45 is the square root of 2 over 2. Okay, so I want you guys to know that. And I'm even going to say, oh, let me get this out. There it is. The TI-84 calculator wakes up pretty slow. Right? So if I go here and we say square root of 2 over 2, do you guys know what that is numerically? Here's square root of 2, come out of there, divided by 2. What is that? That's an irrational number. It's about 0.707, blah, 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 that ratio. Okay, so just so you guys know. All right, so you guys want to know where this stuff comes from. You want to know the definitions of them. Cosine 45, what's that going to be? Same. Why is that the same? Opposite over what? Hypotenuse. So it's going to be opposite over hypotenuse. So that's 1 over the square root of 2. And again, you rationalize the denominator. Is that right? And you multiply your fractions. Square root of 2 over 2. And there's your solution. There's your 6 trig ratios. All right, you guys okay with that one? The little details. What about tangent of 45 degrees, right? You say, okay, here's 45. What's the definition again? Yeah, it's 1 over what? 1. Which is going to be 1. Okay, is that pretty simple, ladies and gentlemen? What do you guys think? Pretty simple? All right, now, that's only 3 ratios. What did they want? 6. Okay. What's the reciprocal of sine again? Cosecant. Good. Okay, which one do I want to flip over? Anybody know? Should I flip over the final answer for sine, or should I flip over the what? I'm going to flip over the 1 over the square root of 2. And you say, why would I flip over 1 over the square root of 2? Because that'll be square root of 2 over 1, which will simply be the what? Square root of 2, ladies and gentlemen. Do you guys see what I'm saying? So if you flip over that number, you don't have to rationalize the denominator because it's already rational. Right, these are the things, the little details you guys want to know. And then what else? Secant 45. Which ratio do I flip over if it's secant? Is it cosecant? Cosine? Okay, so that's going to be the square root of 2 over 1 again, which is also what? The square root of 2. There it is. Now, what about cotangent? Cotangent of 45 degrees. What do you guys do with that? You're going to flip over what fraction? Tangent. What's that going to be? 1 over 1, which is also what? 1. So you might say, can that happen? It sure can. You just use your definitions. Flip over the ratio here. Right? You're going to flip over 1, you get 1 over 1, so the answer is still 1. So these are the 6 trig ratios for the angle 45 degrees. Okay, now these answers will never change, okay? Now, let me be specific, though. What do I mean by these answers will never change? They'll never change for the angle 45, 45, 45, 45 degrees. Okay? If you change the angle, well, you're going to change the answers. Is that right? If you change the angle, you're going to change that. Now, the good news again is, like I said before, there's only 2 special triangles you guys need to know. Only what? 2. This is the first one. So if you know definitions, you could deduce these answers. If you don't know definitions, then you won't be able to deduce them. So what is it? What is the most important thing you guys could ever do in a math class? What do you guys think? Besides your homework, well, know your definitions. What's a good way to get to know them? Yes, absolutely. I'll tell you guys one thing. Flashcards saved my life as a student. In high school, I never did my homework once. Shh, don't tell anybody. I'm doing your homework. Isn't that sad? I was that kid. Didn't do homework. You got what? You got the D's? I got C's. Barely able to pass, and I didn't do my homework. Except when it came to math, I couldn't pass at all. Forget it. When it came to a math class, not doing your homework, I never passed those. I didn't even get D's. Depending on the class. If it was math, it was not even C's, it was F's. Do you guys know what I'm saying? So I had to repeat algebra over and over again until I passed. Beginning algebra. Algebra 1, not even intermediate algebra. That's the deal. But all the other classes, like, I don't know, what else do you guys take? The other classes, I was able to pass without doing homework, but I got a C. You guys know what I mean? It wasn't until I started doing homework did my life change. I went from a kid who couldn't pass algebra to one who got A's just by doing homework. Not only A's, 100%. I'm like, are you kidding me? So what did I learn? Things that I needed to know, I put on flashcards. I had to learn how to study. So I put them on flashcards. I thought just by looking at that paper, memorizing a script or something, didn't work for me. Flashcards did. For a lot of things, just use flashcards. So I used them for a very long time. I was like, okay, I'm going to put some of this stuff on flashcards. The definition of tangent of theta, opposite over what? Adjacent. So on tangent theta on one side and the other side, I put opposite over adjacent. So I'd have a flashcards. There's something about flashcards I can't tell you that can help you tremendously. So that's my recommendation to you guys. Because again, when I say this stuff to you, I can tell you guys, I don't have any of these things memorized. I don't focus on memorization of like numbers really, like in some ways. My memorization focuses on definitions and on the concept. So I can deduce things. And that's what's most important is the art of deduction. Okay? You say, what do you mean the art of deduction? Yeah, how to deduce, how to figure out what's going on. And you start with small tools and you get better and better. So, like the things we already did here. This is again going to be what? Only the second special triangle you need to know, memorize. And I knew how to deduce it. The 45-45 went from a square and creating a diagonal from a unit square, right? This is like the same thing, but it wasn't a unit. It was 2 units. It was an equilateral triangle. So how I showed you guys is the things I used to focus on. So if I ask you the same question here, right? What are the 6 trig ratios? For 30 degrees and what? 60 degrees. You say, what do you mean? Well, this is like the alpha, and then this is like the what? The beta. This is the reason we went over that first kind of worksheet, alpha and beta, really. And again, there's only two special triangles that gives you a wealth of information you want to remember. Only these two. And again, that comes from what class is that again? Beginning what? Algebra. No, sorry. Geometry. That's what that's from. Not beginning algebra. Okay? So, should I have you guys try it? It's always good to get you guys to try this, to wake up. No? You guys know what I'm saying? You already knew this. You already know how to do it. Let's see if you guys learned anything from what we just did, because we went over that. All right, let's see if you guys learned anything. Let's see what you get. Generate the 6 trig ratios for alpha and what? Beta. Okay. Let's try this out, ladies and gentlemen. So let's start with sine of what? 60. What's the definition of sine again? Opposite over hypotenuse. Square root of 3 over 2. Is the denominator rational? So you are done. Just by knowing your what? Definition. Cosine of what? 60 degrees. What's the definition of cosine 60? Adjacent over what? Hypotenuse of 1/2. And there you go. What's tangent of 60 degrees? Now you're at 60 degrees again, and so you say what? Here we go. Opposite over adjacent. Square root of 3 over 1, which is going to be what? Just the square root of 3. And notice something about that. It's already what? The denominator down here is rational. It means there's no radical down there. Okay, you guys okay with that? All right, now let's try something here. I'm going to move this down if I can. Let's do something here like this. Okay. Copy and paste. We're going to do the same now. We're going to do this with what? Sine of 30 degrees. What's sine of 30? What's the definition of sine? Opposite over hypotenuse, so that's 1 over 2. Is this a rational denominator? Yes, so you're done. Okay, good job, good job. Now let's do cosine. Cosine of 30. What's cosine of 30? It's adjacent over hypotenuse. There we go. Tangent of 30 degrees. What's tangent of 30? Do you guys know what tangent is? Opposite over what? Adjacent, but what's the problem here? You guys know? Yeah, we have to rationalize the denominator. So, in other words, we multiply the bottom by the square root of 3 and the top by the square root of 3. And what do you end up with? Do you guys know? You end up with what? Square root of 3 over 3. Ladies and gentlemen, there you go. These are the 3 trig ratios for each angle. And notice I just used the definition. Okay? Remember, if you want to know that definition, put it on flashcards. But didn't they ask for the 6 trig ratios? So if I start here with this and say to you, okay, sine, what about this? Cosecant of 30 degrees now. Remember, I just need to know what sine is. Sine is 1 over 2. So what is cosecant of 30? 2 over 1. Flip that over. And 2 divided by 1 is simply what? 2. Okay, you guys okay with that? You got to know the reciprocals. What about cosine? What's the reciprocal of cosine? In that secant 30. So flip that over. Square root of 3 over 2 is really going to be what? 2 over square root of 3. And there you go. Tangent 30. We're going to flip over 1 over the square root of 3. Is that right? So what's that going to be? Square root of 3 over 1. What's anything divided by 1? It's itself. So ladies and gentlemen, there you go. Okay, so now you have the 6 trig ratios for that 30-degree angle. All right. We didn't do that for what? Yeah. So let's do the 60-degree angle and get all 6 here. So now that's going to be what? Cosecant of 60 degrees. Flip that over. 2 over the square root of 3. What do you guys do now? Square root of 3 over square root of 3. It's going to be what? 2 square root of 3 over what? 3. There you go. What about secant of 60? Flip cosine over, and what do you got? 2 over 1, and now you have what? 2, ladies and gentlemen. There you go. Is that okay? All right. Now what about tangent? Tangent of 60 degrees. Flip that one over. And that's the square root of 3 over 1. So that'd be 1 over the square root of 3. Okay, let me move this over. And what happens now? And there you go. Yes. Which one are you talking about? Oh, secant 60? Okay. So you go to do secant 60, you want to go to, let's see if we get cosine, right? And it's 1 over 2. Oh, did I do tangent 60 twice? I apologize. So let me double check. You know what we got to do? Thank you so much. It's cotangent 60. Good job. Good job. I'm glad somebody's awake. Where's my coffee? There you guys go. Right? Only 2 special triangles you guys need to know. So hopefully you guys work on those special triangles because that's going to be what? A pretty big deal. Okay? Now, take a look at the rest of these here, right? This is number 1 and 2. These are different triangles, by the way. So what I'd like to remark to you guys, that nobody's going to ever ask you to do like sine of 20 degrees. Okay? Does anybody know why? Let me go back to this. Anybody know what I'm talking about? No, they're not going to ask you that question, really. And the reason being is because, let me put it this way. There are no special triangles, really. I mean, there might be, but there's only 3 special triangles. So you only have to worry about those angles, right, for now, right? And anything that we use in relation to that. In the future, you can do sine of 20, but you have to use other tools. You have to use what's known as identities to do something like that. And even then, if somebody says, what if somebody gives me sine of like 8 degrees? Well, you may not be able to do that even with other tools and identities, but it can be done using other methods. So what I want to say to you guys is the foundation of what you need to know how to do, you're looking at right here. That's your foundation. That's kind of like your bread and butter. This is where you start. It's your starting point. It's your reference point, right? It's your point of reference. Yes, you'll have additional definitions And yes, we'll do additional things, but this is your reference, your point of reference. It's kind of like your compass, right? You know where home is. This is where your home is. You always have to get back to home. Okay, so that's why it's important to use flashcards maybe so that you can understand these definitions and start to use them. And that's where it starts. And so if you don't have a good starting point, then, you can't expect to if it's kind of flimsy, you can't expect to sail on through without that starting point. So that's kind of the advice I have to give you guys. And like I said, do I know what it's like to be a student that never did homework? Yes, I do. And that's why I tell you, my life didn't change until I started doing homework like every day. Then my life changed. And anyway, that's the sermon for the day. Change your what? Life. By doing what? Homework. Maybe I should make a t-shirt. What do you guys think? Would you guys buy that t-shirt? Some swag? I don't know. I might have to make a t-shirt that says something like that. Change your life. Do your what? Homework. Anyway, how is this one different? First of all, not all right triangles are oriented in a way you prefer. You still have to use the definitions of opposite, adjacent, blah, blah, blah. You guys understand what I'm saying? So now look at the orientation of this right triangle here. Okay, no big deal. We need to find the missing side, right? So now, what do you guys notice here? This is 90 degrees. What do we call this side over here? The 9, because 9 is represented by that length. That's the hypotenuse. Good. Isn't it always a good idea to know that? Okay, geometry, right? So 90-degree angle. And you go, that's a right triangle. Okay, good. So these others are the legs. Is that true? Now, what side is missing, though? The leg called what? A. That side's given, so the leg called A. Now, here's the deal. Pythagorean theorem says what? A squared plus 4 squared better be what? 9 squared. Okay, you guys okay with that? So that means a squared plus 16 equals what? 25. So if I subtract 16 from both sides, what does it mean about a squared? What do I get now? What's 25 minus 16? Does anybody know? Is that 9? 81. Sorry. I'm thinking 5. It's 81. Good job. Okay, so it's 81 minus 16. $65, is that right? All right, now what is A by the square root formula? Plus or minus square root of 65. And so A is going to be the square root of 65, is that right? Now, is that radical simplified? It sure is. Good job. It's already simplified. Good. Okay. So this is simply the square root of what? 65. So sometimes we don't get a nice whole number. In fact, most of the time we don't get a nice whole number. Most of the time with these right triangles, you're lucky. There's only like a few right triangles that have nice whole numbers. Only a few. The rest are what? I got to double check. There might be more than a few, but they're not so easy to locate. But generally speaking, you're going to get a radical there. Generally speaking. So you want to get used to it. And it's not such a big deal. So if they start saying, okay, I have to do, sine of alpha now, right? So you might say, okay, sine of alpha now, what's the definition? Opposite 4 over hypotenuse, which is 9. So it's 4 over 9. There you guys go. Cosine alpha, adjacent square root of 65 over hypotenuse. There you guys go. Is that right? tangent of alpha, definition, opposite 4 over adjacent. 4 over the square root of 65. What do you guys know again? You have to what? Rationalize the denominator. So there you go. And there it is. There you go. Okay, so far so good. All right, let's do beta now. So beta, we're going to find sine of beta, cosine of beta, tangent beta. So sine of beta, what's sine of beta? What do you guys think that would be? Here's beta now. So I'm going to focus now on beta. Opposite over what? Hypotenuse. The square root of 65 over what? 9. So that's by definition. Square root of 65, 9. Cosine of beta, adjacent. That's the side next to beta. That's not the hypotenuse, right? 4 over what? Over 9. So far, so good. Okay, tangent beta. What's tangent beta? Definition of tangent is opposite over what? Adjacent. So that's the square root of 65 over 4. Okay, so let's try to do here. What's the reciprocal of sine? Anybody remember? We're going to find the other ratios. We got to find all 6. What's the reciprocal of sine? Cosecant alpha. Flip the fraction over 9/4. Is that right? Okay. Now secant of alpha. Flip the fraction over. Flip what fraction? 9 over the square root of 65. Uh-oh. What do you have to do? Rationalize the denominator. So, ladies and gentlemen, when you do, you get what? 9 square root of 65 over 65. There you guys go. Now, what about tangent of alpha? Anybody know what tangent of alpha is? You got 4 over the square root of 65. What's that going to be? You flip that over. That's the square root of 65 over what? Over 4. Did I? Yeah, and I keep doing tangent, cotangent. Sorry. All right. There you guys go, ladies and gentlemen. That's how you get these trig ratios. What about this here for beta? Cosecant beta is what? 9 over the square root of 65. Rationalize again. And you end up with what? 9 square root of 65 over 65. Secant beta. The reciprocal of cosine. secant. Flip the fraction over, 9 over 4. So you got 4 9ths. It's now going to be 9 fourths. That's for secant. Cotangent, beta. Flip the fraction over, 65 over what? 9. Okay, these are the reciprocal identities. So you just have to flip the appropriate fraction over, but you got to know which one it is. Is that right? So how do you get to know which one it is? Write it down on what? Flashcards. Okay, if you have to do that. Now, some of you guys already know this, and if you know this, this is great. Good for you. If you don't know it, here's your opportunity to what? To learn it. Okay, you guys okay with that? Now, what's the title of this? Do you guys remember? Yeah, let me try to get back to browser. Let's go back. This is going to be in Math 241, by the way. Got a worksheets and videos. This is Geometry Lecture actually 2. So did I already assign that to you guys already? I might have. Okay, I might have already assigned it to you. And where's the comments? There we go. So if I did, I want you guys to finish that. All right? You guys okay with that? And that's kind of a review of some geometry definitions that are going to be important for the class. So, okay, ladies and gentlemen, that's it. What do you guys think? Is this easy or is this hard? Is it impossible? Is it good to review? Okay, then we'll see you guys tomorrow. Take care.